Hi everyone, today we're going to be talking about lesson 6.3, graphing radical functions. So a radical function is going to be a function that takes a radical expression and it has the independent variable in the radicand. So the independent variable for us is usually going to be an x, and the radicand, remember, is the location underneath the radical. So if we have a square root function, the parent function for that is f of x is equal to the square root of x. Remember that we don't normally write this 2 here, but you can if it helps you along the way. This is the graph of the square root parent function. Notice that the graph starts at 0, 0. This is different from some of the other functions we've talked about that were continuous and had both positive and negative x values. But this one, notice that the parent function only has positive x values and positive y values. So let's make ourselves a little note here that the graph, the square root graph, starts at 0, 0. This starting point at 0, 0 might change if we do transformations to the graph, which we will talk about today. So we want to go ahead and make a note that a transformation can change our starting point, and then that would ultimately change our domain and range. Let's talk about the domain and range of our parent graph here. Let's remind ourselves first which direction is domain and which is range. So we are going to read our graph from left to right for domain and bottom to top for range. Let's first look at our domain. So this is going to be our x values. We're reading from left to right. Again, the graph does not start until we get to 0. But then once we get to 0, we can see that it continues on because this arrow is going generally to the right and up at the same time, so up and to the right. So our domain is going to be that x is greater than or equal to 0. X will not be less than 0 for our square root parent function. Our range, we are going to start at negative infinity, and the first time that I encounter the graph is also at a y value of 0. After I have that y value of 0, you can see that this graph is generally tending to continue up towards infinity. So our parent function will be y greater than or equal to 0 for the range. Now let's look at a cubed root function. So a cubed root function is going to be designated as the cubed root or third root of x, and this is a graph of the cubed root function. Notice that it looks very similar to the cubic function that we learned about last 6 weeks, but it's kind of turned on its side. This square root function kind of looks like half of a parabola or half of a second degree function. And the reason for that is that those are opposites. Remember that square roots and squares cancel each other out, and so do cubed roots and cubes. For this one, notice that our domain, well, that arrow is pointing to the left and this arrow is pointing to the right. And so since those arrows continue in both directions, our domain is going to be all real numbers. And then for range, I realize that this looks pretty flat, but it does continue to go down and to the left, up and to the right, and so eventually it gets to positive and negative infinity in the y direction as well. So our domain and our range for our parent function are all real numbers, or negative infinity to positive infinity. That means that transformations cannot change our domain and range. Our domain and range will always be all real numbers. Now, one thing to note is that this center point, which is currently at 0, 0, that could move up or down or left or right. depending on what we do to transform the graph. But just because you move the center point does not mean that you have changed the domain or the range.